the number of mosquitoes in around a dam on a certain night can be modeled by this equation. N equals 4000 over 2t minus 1 plus 100t plus 1000, where t equals the number of hours after sunset. Now let's say find the initial number of mosquitoes. So when n equals 0, when t equals 0. So when t equals 0, that is when it starts, so that's initially. Then n equals, and wherever I see a t, I'm just going to put now a 0. So I'm going to have 400 over 2 times 0 plus 1 plus 100 times 0 plus 1000. Now 402 times 0 is 2. 2 times 0 is 0, plus 1 is 1. 400 divided by 1 is 400. That is 0, plus 1000 will give us a 1400 mosquitoes. So that is A done. Number B. In B, they say, what's the average rate of change in the first 4 hours? Now remember, this is some function. And it doesn't matter how this function look like. It can be some weird thing. To find the average, we need to know what's in between 2 points. So we need to find what's the gradient between 2 points. So what I want to know is, what is the number when it is 4 hours? So I'm going to say, so when t equals 4, I'm going to substitute 4 into my equation. So it's going to be 400 divided by 2 times 4. Can you see I use brackets, plus 1 plus 100 times 4 plus 1000. So that is what n is. N will equal 400 divided by 8 plus 1 is 9, which gives us 44.4 plus 400 plus 1000. And that will give us a total of 1,444,000.4 mosquitoes. Okay, now you don't get 0.4 mosquitoes unless you gave it a very good swat, but we are gonna round it down. Doesn't matter what this is. Doesn't matter if this is a 7 or an 8. There's not 1,445 mosquitoes yet. They are still in the making. No pun? Right? So this will give us, rounded off, 1,444 mosquitoes. So now, I'm just going to carry on here with B. So if I want to calculate what is the average rate of change, remember the average rate of change, the average equals the average rate equals y2 minus y1 divided by x2 minus x1. So y2 is 1444 minus, when I started was 1,400, divided by, that was 4 seconds and started at 0 seconds. So that will give us 44 divided by 4. So this is 11 mosquitoes. And because it's right, it's per hour, because it's 4 hours. So what's the average rate? It means that every hour, for the first 4 hours, every hour there's roughly on average 11 mosquitoes more. To do C, they ask, what's the rate of change at any time? Now the rate of change at any time, move out of the sun. The rate of change at any time is the gradient, which is dy dx. In other words, dn. How does dn change in terms of d? So we're looking for dn dt. Okay, so that is what I'm looking for. I'm going to seriously run out of space here. So what I'm going to do is I'm going to rewrite this, and I have to differentiate this in terms of t. So I'm going to quickly rewrite n, and I'm going to say this is 400 times 2t plus 1 to the power -1 plus 100t plus 1000. If I find dn dt now, that's the average rate of change. The -1 goes to the front, it becomes -400. 2t plus 1 stays as it is, but that becomes -2. And then I multiply by the derivative of 2t plus 1, and the derivative of 2t is 2, plus the derivative of 100t is 100. The 1 comes forward, the t falls away, so it's 100, and the 1000 falls away. This will give us now -400 times 2 is -800 over, that -2 goes underneath the line as 2t plus 1 squared plus 100. So that is the rate of change at any time. If we want to know now what is it in D when the change is actually 4 hours, just going to move everything over. If we want to know what is it at all times in D when time is 4, I'm just going to say when t equals 4, when t equals 4, and I'm going to substitute that into my gradient function, which means when t is 4, dn dt equals, and wherever there's a t over here, I'm going to substitute 4 in. Okay, and that's going to give us -800 over 2 times, I'm going to put a bracket for 4, plus 1 squared plus 100. This is going to give us 2 times 4 is 8, 8 plus 1 is 9, 2 times 4 is 8 plus 1 is 9, 9 squared is 81. So it's -800 over 81 plus 100. If I do that to my calculator, it gives us 90.1 mosquitoes per hour. Okay, we're not going to round off the 90.1 mosquitoes per hour because that is just the average. Here we were looking for a number, and I'm just going to try and zoom this out so you can see the whole picture. So with the first question that they've asked us, they asked us for a specific number, so I had to round it off. If this was 11.5, the average rate, you can have numbers down there. So you can have 11.78 because that's a rate. But when you're looking for a specific number, you can't have half a mosquito. And then the same for you. So last recap. Initial time is when t is 0. If I want to find the average between 2 points, I need to find the value before and the value after. And then I get the gradient between the two. If I want the rate at any time, it's the first derivative. If I want to find the instantaneous rate at a specific time, I substitute that into my equation.